So in the new chapter electricity, we should first of all learn about electric charge, because in the chapter electricity it completely deals with the charges and their properties. So what is electric charge? Okay, you can see here, electric charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field, and electric charge is carried by subatomic particles. So generally what happens that subatomic particles means the electrons, protons. So these protons, electrons, they carry one new property, another property. Okay, so this property is termed as electric charge, and they experience a force. What is force? It can be either attractional force or it can be repulsive force when they are brought closer to each other, or when you place them in an electromagnetic field. Okay, so what is electric charge? It is a property of matter by virtue of which attraction or repulsive force can be experienced when they are brought near one another or placed in an electromagnetic field. And this electric charge, this property is actually carried by the subatomic particles. Now we shall come to the kinds of the electric charge. That means what are the kinds, the types. Okay, so you see here that there are two kinds of electric charge, either may be positive charge or it may be negative charge. And these charges, this says that their property, what is their property? Its property is that these opposite charges, or we call unlike charges, attract each other. Suppose one positive charge will attract one negative charge, and similar charges, that is the like charges, repel each other. So okay, suppose here it is a one positive charge. Okay, so if you brought another positive charge near this, suppose it is Q1 and it is Q2, then these two charges will experience a force of repulsion. Okay, why? Because they are like charges. Like charges will repel each other, and if one is positive and another is negative, then they will experience a force of what? Attraction. That's why I call that unlike charge. This is called positive, negative. These are called unlike charges attract each other, and like charges repel each other. Okay. Now we come to some new terms that called in conductors and insulators. Okay, because some metals they are very good conductors, but some metals are not good conductors and they are called insulators. So now we will define how and what. Suppose here first one term another is that the electricity can be classified into two parts. One is called static electricity, another is called current electricity. What is static electricity? When the electric charge resides on an object but do not flow through it, then the electricity on the object referred to as static electricity. That means it is about the study of charges on the object, and these charges will be at rest. Okay, so these charges will not be in motion. So these charges will not be in motion. They are called static charges, and the study of the charges at rest is called static electricity. So simply also known as static electricity. So it may be about the charges on an ebonite rod or a glass rod. Next one is current electricity. When the electric charges flow through an object, then the flow of electric charge is referred to as current electricity. So what happened that when we apply some electric field in a conductor, then the charges in the conductor starts flowing from one end to the another end. Okay, from one terminal to the another, so the charges starts flowing. Then the study of the charges, that is called electric charges in flow. Okay, then we call that study of the charges while in motion will be called current electricity. So example given, for example, the electric charges that is flowing through metals constitute your current, electricity. Okay. The next term we will define is the conductor. So I have mentioned what is conductor. There are some substance through which the electricity can flow are called conductors. Okay, now I am going to show you. Suppose this is a one. What is this? This is a one conductor. So when you apply some potential, apply some potential between the terminal, then current starts flowing through the conductor. Okay, so what is flowing? Current flowing. Then this is called conductor. And if this is not conductor, then current will not flow. That is means in case of insulator, current will not flow, but in case of conductor, current flow through the object. There are so many examples of conductors like the metals. The metals are good conductors of electricity, and graphite, then gas carbon are also the only non-metals which are very good conductors of electricity, and all the ionic compounds in solution are good conductors of electricity. Okay, so these are the some important points that we can easily memorize them. So metals are good conductors. Graphite and gas carbons are they are non-metals, but they are also good conductors, and all the ionic compounds in the solution are also form a good conductors of electricity. Next topic is your insulator. So the substance through which electricity cannot flow are called insulators. Obviously there are so many examples. You can see glass, paper, porcelain, rubber, and plastic, wood. These are some solid insulators. Okay, and some organic liquids are also like chloroform, carbon tetrachloride, alcohol, benzene. These are examples of insulators. The next topic is electric charge and its unit. So we have already defined what is electric charge. That is the property of a body by virtue of which attraction or repulsive force can be experienced when they are placed near one another, or these charges are placed in an electric field, external electric field. Then there will be what? Attractional force or repulsive force they will experience. And now its unit. So what is the unit of electric charge? So the unit is called coulomb. The SI unit of electric charge is what? Coulomb. Okay, so the definition of 1 coulomb is that a body is said to have 1 coulomb charge if it has 6.25 into 10 to the power 18 electrons on it in excess or in deficit as compared to the normal number of electrons. So no need to memorize, simply you memorize that charge on an electron is equal to 1.6 into 10 to the power minus 19 coulomb. So the SI unit of, just try to memorize that charge on an electron is equal to 1.6 into 10 to the power minus 19 coulomb, and the SI unit of electric charge is your coulomb. Okay, now I will explain about electric current. So what is electric current? The definition is that the rate of flow of charge from a body at higher potential to a body at lower potential is called electric current. As you know that charges always move from higher potential to lower potential. Suppose one example I like to give you, that when we keep one object at certain height from the ground surface, then it has tendency to come to the ground. No? Why? Because at this point this object have some high potential. Okay, this object have higher potential and it always has a tendency to come low potential. Similarly, in case of electric current, the charges have a tendency to move from high potential to low potential. Okay, so whenever we apply electric field in a conductor, suppose this is a conductor, you apply a electric field, then the charges have always tendency to move from higher potential to lower potential. So we consider this plus to have a high potential and negative is a low potential. So so what is electric current? It is defined as the rate of flow of charge. Okay, rate of flow of charge, that so we call simply I is equal to Q by T. It is Q by T, rate of flow of charge from a body at higher potential to a body at lower potential. So this is the definition of electric current. Electric current also mathematically may be defined as electric current is a charge flowing in unit time. So here you can see electric current is the charge flowing in unit time. Now the unit of electric current. What is the unit of electric current? Unit of electric current is your ampere. Okay, is ampere. So you see here I is equal to Q by T. So Q means SI unit of Q means coulomb, and T for tight. What is the unit of T? T means second. So coulomb per second. So 1 ampere is equal to, I can say 1 coulomb 1 per 1 second. Okay, therefore 1 ampere is equal to, I can write 1 ampere is equal to 1 coulomb per second. 1 milliampere means 10 to the minus 3 ampere, and 1 microampere means 10 to the power minus 6 ampere. So you will find sometimes in case of numerical that the current may also written as like 1 mA, 1 microampere. Okay, so mA means milliampere. That means you have to write 1 milliampere is equal to 10 to the minus 3 ampere, and microampere means 10 to the power minus 6 ampere.